So we're going to solve absolute value equations and inequalities. So let's at least get started on this stuff. I don't know if we'll conclude it today, but at least we'll get started. Now, when you work in your homework, you're going to get a problem like this. So just for the vocabulary part of this, when you have something like this, where you've got the absolute value and a variable inside that absolute value, an equal sign, that's an absolute value equation. All right, yeah, doesn't make, it makes kind of a lot of sense. If I switch that up a little bit, I can make that an absolute value. What would you guess this second one is? Instead of an absolute value equation, this is an absolute value
inequality.
Inequality, yeah, thank you. Now, the solution to absolute value inequalities, probably going to wait till next time. But let me talk about solutions in general. And I'm going to start it with this one right up here. If you had 3x minus 2 equals 10 on a test, you'd probably say, hey, the instructor's favorite sports team must have won over the weekend or something like that. That's going to be pretty easy. You get x equals 4. But what I want to draw your attention to is a graphical interpretation of this. I could think of this as, for instance, y equals 3x minus 2. And I could think of this as, say, y equals 10. So that's this one right here, horizontal line. And what I want to draw your attention to is the place where they intersect at x equals 4. So if I was, for instance, letting you use Desmos on an exam, you could take Desmos and just click and find that point of intersection. That would be your solution. Let's take a look at an absolute value equation then instead. This time, if I wanted to pull the same trick, I could say, all right, well, I could let y equals the absolute value be one graph and y equals 27 be the other graph. Hopefully you're used to the idea that y equals a number is just going to be a horizontal graph. And then I've got this, which is y equals the absolute value of x. The big thing I want to get across to you is this. How many solutions do I have for this equation? Two, right? Two solutions. There's two places at negative 27 and positive 27, two different things that you can plug in here to make this work. So in general, that's what's going to happen when you're working with absolute value equations. In general, you're going to get two solutions. Now, do you always get two solutions? No. In fact, other things can happen. Let me just open up Desmos real quick and show you, kind of some of the other things that can happen. We got y equals the absolute value of x for one graph, and then let's do y equals a constant for, let's see, maybe use ax. Let's just make that a now. So a lot of the times when you're solving these types of problems, you'll get two solutions, right? You can see them, you can click on it if you're working in Desmos, you get a solution here, solution here. But sometimes, like in this case, how many solutions do I have now? Just one. Or if I go even lower, now how many solutions do I have?
No.
None. So it's kind of strange that you could get 0, 1, or 2 different solutions depending on what's on that right-hand side. Now, it's just something to be aware of. A lot of times you're going to get those two solutions. But the question is, how do you find those two solutions? And my suggestion is that you just actually write down two different equations and go looking for them. Look for the positive solution and look for the negative solution. And that's how I'm going to work with absolute values in general. So let's take a look at example C, which is the absolute value of x minus 9 equals 2. Now the reason you're getting those two solutions is because when you're dealing with an absolute value, you just want to make sure you're getting, for instance, in this case, a 27. Doesn't matter if you have a negative 27 or a positive 27, there's two different things you can put in the absolute value to get that number. One of them happens to be negative, one of them happens to be positive. So the same thing is going to be true here, it's just going to look a little different. When I grade these things, I grade them out of 6 points. 2 points go for the easy case, that's the positive case. If what's in here is positive, for instance, if I had the absolute value of 8, do I really need the absolute value there? No, I can get rid of it. But if I had the absolute value of negative 8, the absolute value of negative 8 is also positive 8. One way to think of this, though, is to get it out of the absolute value, you're taking its opposite. The opposite of negative 8 is positive 8. How does that apply over here? If this is positive, I don't need the absolute value. I can just take it out of the absolute value. If this is negative, I've got to take its opposite to get it out of the absolute value. And so that's the negative case. Notice what I'm not doing. I'm not just making it x plus 9. I'm taking the opposite of the whole thing there. Solving this is pretty straightforward. We'll add 9 to both sides here. Over here, I've got a little bit more work to do. I'll distribute the negative, then subtract 9. And then divide both sides by negative 1. And I get x equals 7. Okay. So I get two solutions. Do they both work? Do both of these solutions work? How do you suppose I could test that? Yeah, put both solutions back into the original equation. 11 minus 9 is 2. Absolute value of 2 is 2. That one works. 7 minus 9 is negative 2, but its absolute value is a positive 2. So again, that works. Great. Great. Let's try another one. Or maybe not. Let's see if we can't make some headway, maybe thinking about it. So example D. Example D. Absolute value of x minus 2.9 equals negative 16.3. Okay. Well, typically speaking, when you solve absolute value equations and inequalities, you're going to get the absolute value by itself first. If there's a negative on one side of the equation or inequality after you isolate the absolute value, stop and think. So if there is a negative number on one side after you isolate the absolute value, stop and think. Well, I guess we meet that stop and think criteria. And I want you to think about what happens when you take the absolute value of a number. Going back up here, the absolute value of 8 is 8. The absolute value of negative 8 is also 8. In fact, when you take the absolute value of a number, you always get something positive or 0. how's that apply down here? Can I take the absolute value of something and get a negative 16.3? Can you get a negative number when you take the absolute value of something? No. So what's that tell me about this problem here then?
Fine.
I think that's in the right spirit. Let me just give it a different vocabulary. No solution. There is no solution. Yeah. You can't do this one. There's nothing you can take the absolute value of to get a negative 16.3. That's it. So there's no solution there. Now that's going to probably be the exception rather than rule as far as your absolute value problems are concerned. But, you know, do keep an eye out for that one. All right, let's try some more here. Let's try example E. Absolute value of 4x minus 2 plus 7 equals 21. Okay. Now, I know I just finished talking about getting a positive case and negative case. We're going to do that. But remember one thing I mentioned here. You have to isolate the absolute value. That's our first step in working with these equations and inequalities, is you've got to get that absolute value stuff by itself. What do I mean by that? What do I have to do to isolate that? Does anyone want to guess?
Subtract 7?
Yeah, subtract 7. Subtract 7 from both sides. The absolute value of 4x minus 2 equals 14. When I grade your exams, I'm going to be looking for two things. I'm going to be looking for the positive case and the negative case. If you just wrote that down and not much more, you'd probably get at least a point writing just that much down. All right, because that's telling me you understand that there's more than one possible solution that we have to look for. The positive case, that's the nice case. That's just going to be 4x minus 2 equals 14. That comes from just dropping the absolute value there. Does anyone want to take a look at the negative case? What's that going to be for me? Angel?
Negative and over parentheses 4x minus 2 over parentheses equals 14.
Perfect. Basically, you're assuming that what's in here is negative. To take it out of the absolute value, we'll take its opposite. So, perfect. 4x equals 16, x equals 4. That's one solution. Over here, negative 4x plus 2 equals 14. So negative 4x equals 12. X equals negative 3. That's our other solution. But they're both solutions. You can check that by plugging it into the original problem. Don't plug it into something farther down the line. Plug it into the original problem. Nice. Nice. All right, let's do one last one here. Example F. The absolute value of 4x, oh, sorry, I did that again. Negative 3 times the absolute value of 2x minus 9 plus 19 equals 19. Hannah, suggestions?
Do you subtract a 19, please?
Yeah, let's subtract 19 from both sides. And I get negative 3 times the absolute value of 2x minus 9 equals, well, 0. Great start. Zach, keep going. What else can I do here?
I believe you could distribute the negative 3.
Actually, you can't. We can't distribute the negative 3 because this is inside the absolute value and this one isn't. So,
divide by 3.
No, not quite. Appreciate the ideas though.
Divide by 3 then.
Yeah. Again, going back to this, we want to isolate the absolute value. So I'll divide both sides by a -3. And there's where it's what we wanted. 2x minus 9 equals 0. Actually, the absolute value of 2x minus 9 equals 0. This one is a little bit different than the last one. You can look for a positive case and a negative case, but you're not really going to find them. In the last one, when I did a positive case and a negative case, it made a difference. Here, it won't make a difference. So if I do a plus case, 2x minus 9 equals 0. If I did a minus case, negative of 2x minus 9 equals 0. I'm going to get the same thing both times. 2x equals 9, x equals 9/2. Distribute the negative. Negative 2x equals -9. X equals -9 over -2 simplifies down to x equals 9/2. So oddly enough, I'm only getting one solution here. That's okay. You can kind of expect that when you get down to the absolute value equals nothing. And the reason for that is back up here. When you have the absolute value equal to 0, let me see if I can't get that perfectly down to 0. There's only going to be one solution, and that's what's inside the absolute value has to be 0. There's only one place what's inside the absolute value equals 0, and it's 9/2. So only one solution there. All right. Should we do one more? All right. One more. Example G. The absolute value of 3x minus 5 plus 7 equals 35. So going back to hopefully some more familiar territory. Ooh, I'd be wrong to set up a positive and negative case right away. Why is that?
Get rid of the absolute value.
Yeah, you got to get the absolute value by itself first. So let's do that. And to do that, what do I need to do?
Subtract the 7.
Perfect. Subtract 7 from both sides. Absolute value of 3x minus 5 equals 28. Now you can set up your positive and negative case. I think only one of these is going to work out even. Well, it's okay. Sophia?
Sorry, where on the handout is the problem?
Oh, it's not.
Oh,
Yeah, it's not.
can you go back so I can write it down?
Right there. So this one's a little ad-libbed. I just wanted to give you one more that worked out in a little bit more typical fashion. The one that I called example F here, that's going to be unusual to get something equals 0 in an absolute value equation. The other example that's kind of unusual is example D, having something with a negative here. The negative though, that's a nice friendly one. That means there's no solution. All right, if you got the absolute value by itself and it's equal to something negative, there's no solution. Example F, a little bit odd. So I did want to get back and look at some more typical examples, and this would be a more typical example. So add 5 to both sides, Over here, I distribute and then subtract 5 from both sides. Negative 3x equals 23. What are my two solutions?
11.
11 and
Negative 23.
negative 23 over 3. Perfect. Two solutions. That's often what's going to happen when you work with the absolute value equations, but not all the time. Sometimes you get, one solution, sometimes you get no solutions. So, beautiful. All right, we'll have to do absolute value inequalities next time. So until then, see ya.